22. So let's take a look. It can be any function. We know how to graph these functions. So 22. We had at least 6, even probably 7 different piecewise defined functions. So it may have 2 branches or 3 branches. It doesn't matter. So we can make one up or just look at that one. It doesn't matter. So let's say f of x equals natural log x for x greater than or equal to 1. And let me stop sharing, sorry. And x squared for x less than 1. Now, pay attention to the fact that specifically in this particular problem, so we are asked a lot of things here. Number 1, graph it. Number 2, continuous everywhere. Number 3, differentiable everywhere. And number 4, continuity at a point. And number 5, find the derivative. So this problem is complex. It deals with algebra, it deals with graphing, concept of continuity, concept of differentiability, the definition of continuity at the point. So we've done all these, and I strongly encourage you to review test 1, test 2, and test 3 reviews. Definitely, before the final. Also, as you know, there are at least 6 or 7 prior semesters. All of them have at least an hour and 15 minutes for each. And also a final exam review, all of them, 6, 7 semesters, prior semesters. So you can watch and watch and watch a lot of problems. I also, you also have a previous exams to look at with solutions. Okay, so let's look at this problem. Remember how we attack this, how we start here. So 1 to infinity is the interval notation for this. And for this one is negative infinity to 1 with parentheses. You have to create the table. For full credit, you must create the table in which you present the information given here, which is to the left with a parenthesis and to the right with a bracket. I strongly recommend right on top of, from 1 to infinity, write natural log x. And from negative infinity to 1, please write x squared. And then plug in some numbers. And of course, I didn't mean to write that. I meant to write the 0 here. So this is positive 1. So of course, you will have, we need ordered pairs on both sides of the break if you want. So this is of course 1. And 1 here will give us 0. And yes, you have to plug in another ordered pair, another x for a second ordered pair. So this is natural log 2. I don't know exactly what natural log 2 is. I need an approximation, natural log 2. 0.69, so approximately 0.7. So this is what I need to graph this function. I don't need more points. This is quadratic, so at negative 1 is 1, at 0 is 0, and at 1 is 1, but it's an open point. So we all know how to graph x squared. So this is x squared. Now when we graph natural log, remember this is the graph of natural log, but I have to start here. I cannot graph anything to the left of 1. So here's the graph. And this is entire f of x. Again, you don't have to graph it in 2 colors. I'm graphing it in 2 colors because I don't want to see this and then this. That's not going to be a function. Now, is this function continuous at 1? No, it's not, because the limit from the left is 1 and the limit from the right is 0. So not continuous at x equals 1. If you want, it's continuous from the right, but it's not continuous at that point. Obviously not differentiable at x equals 1. Because if it's not continuous at a point, it cannot be differentiable. What will be f prime then? When I differentiate x squared, I get 2x for x less than 1. And when I differentiate natural log x, I get 1 over x for x greater than 1. I can no longer include the equal symbol because this function does not exist at 1, because f of x is not differentiable at 1. So that addresses the graph, the continuity, the differentiability. The continuity of the point is the definition. So this is done. So this is the last item that I have to write. So continuity at the point, the definition of continuity at x equals 1 in this case is the limit as x approaches 1 from f of x should be equal to the limit of f of x from the left. As x approaches 1 from the right should be equal to f of 1. In this case, it is not. But this is a definition. The problem was asking me to write the definition of continuity at a point. You don't have to write it at 1. You can write it at x equals a. That's fine too, in general. Whatever you want. And that's it. That's all there is to it. So that was the piecewise defined function. So definition of continuity at the point, if a function is continuous and differentiable, it cannot be in this case because it's not continuous. If it's not continuous at x, it's differentiable everywhere else. That's why I was able to write or find a derivative. So this is different. This function f of x is differentiable everywhere except at 1 because it's not continuous at 1. It has a jump. This is jump discontinuity. And that's it. So just review the most important functions. So you have those ready. So what will be the most important functions? X squared, x cubed, the square root of x, the absolute value of x. Oh, what was that? The absolute value of x, the exponential function. As you know, it's increasing on all its domain. E to the x, natural log x, 1 over x. We graphed it so many times. I'm sure you got tired of it. That's 1 over x. Good. Anything else? What would you like to continue with? Any questions on the previous problem? Is anyone with me? What are we doing next?
We can do limits.
Okay, very good. So let's look at limits. So I selected 21, 31 on 124, and 69 on 113. So I can put this away. So let's take a look. Let's start with 113. 113. Feel free to choose other problems, of course. 69. So we have g of x equals 2x minus 5 divided by x minus 3. And they want us to find the limit as x approaches infinity from f of x. Oh, from g of x, of course. I'm copying from something else now. 69 we said. G of x, yes. And when x approaches 3 from either side. So limit as x approaches 3 from g of x. So we are asked to determine two different things. Let's start with the first one. So that's my page 4. So we have limit as x approaches infinity from 2x minus 5 over x minus 3. Now, if you remember what we do here, we plug in first. So the numerator goes to infinity, the denominator goes to infinity. So if that's the case, then if you also remember what we did when we discussed these limits, we factor out the degree. I see that both have the same degree, but it doesn't matter. I factor out the degree. If it's the same, fine. If it's not the same, I still factor out the degree for each. The degree here is 1, so I factor out x. So I have 2 minus 5 over x. It happens that the denominator has the same degree. I have to factor out x, and I have 1 minus 3 over x. So I'll simplify x with x. And again, if you remember, when x approaches infinity, 5 over infinity approaches 0, and 3 over infinity also approaches 0. So then the limit is 2 over 1, which is 2. I would immediately write, because it's x approaches infinity and the limit is 2, means that y equals 2 is a horizontal asymptote. Now for the other limit, which is the limit as x approaches 3 from 2x minus 5 over x minus 3, the numerator, I have to plug it in to see what situation we encountered here. 3 times 2 is 6, 6 minus 5 is 1, and the denominator is 0. I cannot draw a conclusion because it's x approaches 3 from either side. I cannot write anything yet. I have to first determine the limit as x approaches 3 from the left, and then the limit as x approaches 3 from the right, of course from the same function. And then I will draw a conclusion. The numerator still goes to 1. Now the denominator, I have to establish the sign. How can 0 have a sign? Well, as x approaches 3 from the left means with a 2.9. Can anyone tell us the sign here? Is anyone paying attention? Please. So Brian, what is the sign here? Okay, Brian is lost. Ezra, what is the sign here?
I'm not sure.
You have to plug in 2.9. What will be the sign then?
Negative.
Sure. So this is negative infinity. 3 from the right means 3.1. Can anyone plug it in and tell us the sign?
Negative.
Well, 3.1 minus 3 cannot be negative.
Oh, wait, positive.
Awesome. So then the answer is positive. So this is negative infinity and this is positive infinity. So what will I write as the final answer for the limit of this function as x approaches 3 from either side? Anyone, please. David, what do you think? Okay, David is not with us. Who else would like to say something?
Negative infinity, positive infinity.
I cannot have two answers. So if I'm going north, I cannot tell you, Ezra, I'm going north, but actually south. You understand what I'm saying, right?
Yeah.
If I'm going north, I cannot go south. If I'm going south, I cannot go north. Not at the same time. So what is the answer?
Negative.
Anyone else? Okay. If one side is going to negative infinity and the other side is going to positive infinity, what will the answer be for the limit from either side?
Does not exist.
Exactly. Good. This was 113, page 113. Now we want to go to 124 for 21 and 31. Okay. Let's take a look. 1, 2, 4. 21. 21. Right here. So limit as x approaches 1 from x squared plus 5x minus 6 over x squared minus 1. Like always with all possible limits, everything, I see a lot of shadows here. I don't know what to do. Okay, sorry about that. So we always have to plug it in. When we plug it in, what do we get in the numerator? And then what do we get in the denominator? Anyone, please.
0.
Yes. And I'm assuming you said 0 for both. Good. This is good. This is not good. We know that this has no hope, but this one has hope. What will be the next step? What should I do? Anyone remembers what we have to do next?
We put the bottom part onto the top.
No. So if we plug in x equals 1 and we get 0 over 0, there must be a factor of x minus 1 in both. Mandatory. Otherwise, we will never get 0. So if I have x approaches negative 2 and I get 0 over 0, then a factor of x plus 2 must be in both. If I say x approaches 3 and I get 0, a factor of x minus 3 must be in both. So in our case, we have x approaches 1. So there must be a factor of x minus 1 in both. But I have to discover what else is there. So what do you think? This is guaranteed. Otherwise, we will not get 0 over 0. But I also need to determine the other two factors. So what will they be?
The bottom one is x minus 1.
I
Oh, no,
al-
x plus 1.
Perfect. Awesome. What about the numerator? Great job.
X plus 6.
X plus 6. Then we will have to simplify as we did. And now I can determine the limit. I can drop the limit operator because I'm applying the limit to this, and I will write an answer. What will the answer be? Anyone, please? What would the answer be?
7/2.
Thank you very much. 7/2. Perfect.